Hello guys, welcome to CS Tutorials. Today we will be solving the problem add two numbers, and it's a medium elite code. Has a lot of likes and also it's a pretty common question. And the description says you are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, which is going to be very helpful, and each of their nodes contain a single digit. Add the two numbers and return it as a linked list. You may assume the two numbers do not contain any leading zero except the number zero itself. In the example we're given here, it says we have a linked list 243, which is in reverse order because that is actually 342, and we have 564, which is actually 465, and the output is 708, which is actually 807. So how do we approach this problem? We're gonna have two pointers and we're gonna have a sum and a carry. So we're gonna add the sum. We're gonna add 2 plus 5 will give us 7. Now we'll have add 4 plus 6. The sum, we're gonna have 0, and then the carry is gonna be 1, which we're gonna move over to the next value. So we have 3 plus 4 plus carry, which will give us 8. And we can solve this in multiple different ways, but I'll go ahead and use this approach and we can see the solution and check the time complexity. What we start with is our answer. Our answer is going to be stored in answer, which is going to be a new list node of 0. Then we also need to define our pointers, P1, which will be equal to L1, P2 should be equal to L2, and current, which will be equal to um, answer. Then we need to define our carry, which will be equal to 0. I will also define an x and initialize that to 0, and I will explain why I'm doing this, and the y, it should be initialized to 0. And this we're going to use to store the value of P1 and P2 and sum that together to get our sum. So what we're going to do next is loop through P1 and P2, and while we loop through them, what we want to do is um, make x equal to P1 if P1 is not equal to null. We'll make it equal to the value of P1 equal to P1 dot var, else we give it a value of 0, and we'll do the same for y, but y will be pointing to P2 is not equal to null. Make it P2 dot var, else make it a 0. And after this, what we want to do now is define a sum. In sum will be equal to um, our carry plus x plus y, and we now calculate our carry, which is now equal to sum divided by 10, and we have the carry sum divided by 10. Now we want to say current node dot next will be equal to new list node of sum modulus 10. That helps us to make sure we're not adding two values. Um, we're adding just a single digit and not two digits. And we need to increment our cur to point to the net to move it over to the next value in the linked list. And when this is done, we now need to um, increment our P1. If it's not equal to null, we want to say P1 be equal to P1 dot next. And same thing, if P2 is not equal to null, we say P2 is equal to P2 dot next. And finally, if we're done with the loop and we get to the end of everything, we have 3 here, we have 4, this is where P1 and P2 are pointing. What we need to say is if our carry is greater than 0, we want to handle that. We want to say um, current dot next, current dot next is equal to new list node of carry, and we return answer dot next. And I will run this code so we can see. And I'll go ahead and submit it. And we see it's 1 millisecond faster than online Java submission, and the time complexity is of the maximum between both linked lists. So it's of m, O of maximum n or m. Thank you. If you like this video, if you find it very informative, please like and subscribe. Thank you.